Dear student, myself T.Y.B.TECH, I again welcome to all of you for my online lecture series during this lockdown period. Dear student, I have already started unit number 4, that is network layer, and today I have another online lecture on the same unit for all of you. So the topic of discussion for this online lecture is Internet Protocol version 6, that is IPv6. So IPv6 is the next generation protocol designed by IETF, that is Internet Engineering Task Force, to replace the current version Internet Protocol, that is IPv4. So IPv4 we already covered in the first online lecture of this unit. IPv6 fixes a number of problems in IPv4, such as the limited number of available IPv4 addresses. It also adds many improvements to IPv4 in areas such as routing and network auto configurations. IPv6 is expected to gradually replace IPv4, with the two coexisting for a number of years during a transition period. So this is IPv6. So IPv6 is the next generation protocol designed by that particular IETF, that is Internet Engineering Task Force. IPv6 is expected to gradually replace the particular IPv4 because of IPv4 having limitations, as limited number of available IPv4 addresses are there. So this is about the IPv6. What's the addressing? So IPv6 addresses are 128 bits long and are identifiers for individual interfaces and sets of interfaces. Since each interface belongs to a single node, any of that node's interfaces unicast addresses can be used as an identifier for that node. A single interface may be assigned multiple IPv6 addresses of any type. There are three types of addresses, that is unicast, anycast and multicast. Approximately 15% of the addresses space is initially allocated to the reserved addresses such as NSAP, that is Network Access Service Point addresses, and IPX, that is Internetworking Packets Exchange addresses, etc. The remaining 85% is reserved for the future use. So IPv6 having that different addressing modes, that is called as, we can say that the classification of that modes are nothing but unicast, anycast and multicast. So out of 100%, approximately 50% are utilized by network access service points and that is internetworking packets exchange addresses. The remaining 85% reserved for the future use. So let's see the classification one by one. So first is unicast, an identifier for a single interface. A packet sent to unicast address is delivered to the interface identified by that particular address. So this is the unicast addressing mode. Anycast, an identifier for a set of interfaces that is typically belonging to different nodes. A packet sent to an anycast address is delivered to one of the interfaces identified by that addresses, that is that nearest one according to the routing protocol measure of distance is there. So this is the second addressing mode called as a anycast. And the third one, that is multicast, an identifier for a set of interfaces typically belonging to the different modes. That is, a packet is sent to a multicast address is delivered to all the interfaces identified by that addresses. So there are no broadcast addresses in IPv6. Their function is being superseded by multicast addresses, whereas in IPv4 there should be a broadcast addressing mode is also there. Now move towards the features of IPv6. So this is the most important feature we have about the address size, that is 32 bits is increased to 128 bits in IPv4 v6 protocol. This is the most important thing, that is the feature of IPv6 is nothing but the address size, that is 32 bits is increased to 128 bits. Now move towards the header format of IPv6. So IPv6 having the header format as shown in the particular figure. So that header format again contain the various fields, that as VARS, that is version, priority, flow level, payload length, next header, hop limit, source address, and the particular destination address. So these fields are seen one by one in the next field. Next. So VERS, that is nothing but identifies the protocol as a version. So in this case there is a version number is 6, that's why we can call it as a IPv6. Priority identifies the particular priority characteristics. To whom first will giving the particular priority, it will be defined by this particular field. Payload length specifies only the size of the data being carried. It does not include the header. It specifies only the size of that particular data which is carried. It does not include the header length of the particular packet. Next field is hop limit, corresponds to IP's time to live. That is, this field is present in IPv4, so this field is exactly matches with the hop limit in IPv6. So datagram is discarded if hop limit countdowns to 0. Flow label divided into two parts, one used to define a specific path, the other to specify a traffic class. Routers use the value in the flow label field to route the particular datagrams. The next field is next header, used to specify the type of information that follows the current header. The next is extension headers. So datagram consists of IPv6 header followed by greater than or equal to 0 extension headers, followed by data for extensibility. So as shown in particular figure, so we have the base header, that is called IP header. Then after there is optional extension header 1, extension header 2 up to extension header n, and the actual data is there. So data area represent the actual data of the particular packet along with the base header and the extension headers. So next is audio and video, allows the network to establish high quality path for certain types of data in IPv6, that is nothing but audio and video. Then next is extensible protocol. So IPv6 does not specify all the possible protocol features. A scheme is implemented allowing a sender to add the additional information to the particular datagram. So that is called as an extensible protocol. So now at last let's move towards the difference between IPv4 and IPv6. So we have the three columns, that is in first column we have the IP service parameters, and in second and third column we have IPv4 and IPv6 solutions which is provided by that particular protocols. So first service is addressing range. So in IPv4 32-bit network address translation is there, whereas in IPv6 128-bit multiple scopes are there. The second service is auto configurations. So in case of IPv4 there should be dynamic host configuration protocol, that is DHCP, whereas in IPv6 serverless reconfigurations, or it may be a DHCP, that is dynamic host configuration protocol. The third IP service parameter is security. So here IP security is there, whereas in IPv6 IP security mandated works end-to-end service. The fourth parameter of IP service is mobility. So in IPv4 is mobile IP, that is mobile internet protocol, whereas in IPv6 is mobile IP with direct routing is there. Next is quality of service. So differentiated service, integrated service also in IPv4, whereas in IPv6 differentiated services with the integrated services. That is quality of service, nearly most of the IPv4 in IPv6 case are same. And the last parameter of IP service is IP multicast. So here IPv4 IGMP, that is Internet Group Management Protocol, as well as PIM and multicast BGP group. So whereas in IPv6 MLD, PIM, multicast BGP and scope identifier is also present in IPv6. So this is the basic difference between IPv4 and IPv6 we have, along with the IP service parameters. So with this I have finished today's online lecture. Hope all of you understand this topic very well. This topic is also very important for exam point of view. Thank you very much.